With Seneca 5, we're out of the Seattle area and sometimes North Carolina. We're in the process of moving. So we've got a system called ALOHA, which is a modular architecture that I wanted to show today. Give you an idea of some of the things that we've been doing internally. This applies, I thought, to the topic of professional software because of some of the features that it brings. The ability to promote code reuse. One of its strengths is the ability to do team development, something that's difficult to do in LabVIEW. Those of you that work on larger teams might appreciate some of the stuff that ALOHA does to help isolate one part of the application from another. And just do some simple GUI management stuff that takes some of the burden away from making sophisticated GUIs and error handling. Just some of the features that we look at. So I want to look at what is ALOHA, give you a demonstration of it, and then dive into how it works. And some of that I'll just kind of gauge based on your reaction. So if you can give me some feedback. If the what is part is part, I've given this presentation to less technical groups and have to spend more time there. I think you guys will probably catch on to that pretty easily. And if you're more interested in diving down into the guts of how it works, then that's the kind of question we can certainly spend more time down in there. So, what is it? ALOHA is a modular framework. It's for creating LabVIEW applications. It's written completely in LabVIEW. And it basically lets you create small applications, small modules that come together to make a larger application. And it provides a lot of housekeeping tasks and common background services so you don't have to implement them. So, what is the first question?
Product or free or?
It's a free thing. Oh yeah, it's free. I did want to highlight that, thank you, because before we get going in it, this is not something we're trying to sell. This is something that we've used internally, and we think it's a good system, and just want to put it out for consumption and for feedback and that sort of thing to the rest of you. That I think you can profit from at least some of what you'll see here, even if you don't use all of the ALOHA. And I'll show you at the end. You can download it from our website. So the first question is, do we really need another framework, another architecture? And I know that's one of those things that people will have polarizing opinions about. But I think we do, because I think that one size does not fit all, and we want to be continually having options of what kinds of frameworks that we work in. Everyone here probably has their own, formal or informal. If nothing else, you're using the last application you wrote and making a copy and making the next one. So that's an architecture too. So, and we noticed ourselves doing that and wanted to kind of confine the problem into something that was more specifically defined. So every architecture has good and bad points. Everything that you do when you make an architecture is about making a decision. And deciding to do something means you're deciding not to do something else. So you've got these balances between ease of use or lots of features, and free-formed and structured, and all those kinds of decisions that you make that determine the kind of architecture that it is. And I guess the point of the pictures here is, in the world there are many different types of architectures, and many of those are very specific use, and there's room for all of them. So I want to show you the architecture that we've developed. So this is kind of the general philosophy that we had going into it, that the purpose of an architect is to design using the building analogy, to design what the building is going to look like, to make the plan for the building. But then there are a bunch of construction workers that build that building. They're not the architects, and I don't want to burden them having to develop architecture, having to understand how all the intricacies of things work, but just let them pick up their hammers and saws and actually get to work. So ALOHA tries to make that more possible. So the general purpose of any application framework is to constrain the problem to a particular domain. It enforces common coding styles, takes care of some housekeeping tasks. All of those things are things that help confine the problem, which is for good and for bad. As I said, you make one decision, you're deciding to not do other things. So if you provide a way for it to be done, then that's the way you expect it to be done. An example of a framework is TestSpan, where its purpose is to write test code. And you can do that with LabVIEW. We've all probably done that. But instead of coming up with a blank VI and deciding how to structure a program from scratch, TestSpan gives you a framework. You have a specific way that you add tests. It tests A, B, C. It does looping and those sorts of things. It constrains the problem to writing a test. But you wouldn't want to make GUI with it. It's for a particular purpose. So the way that we did it in ALOHA is we tried to focus on modularity and write small modules that are easy to understand, that encapsulate one piece of the code and then connect it to the other pieces. And this would be kind of following a similar model of many of the platforms that we see today. Probably the best analogy is like the Android screen here with the widgets that you can put on the screen. You've got your application is essentially, in this case, the whole portable device that you have. But you've got these little applets, these little widgets that come together to make that application. And they might be isolated from each other in their function, but they also might have ways that they intersect and communicate with each other. And this is an example ALOHA screen of how we do this in LabVIEW. So there's the application, which is the outer shell of the program, is just a container application. It's kind of a blank space. And then the agents or widgets are inserted into that. So all of the things you can see that are color highlighted with a call out, those are separate VIs that are running inside the space of this container application. You can't hear the sound on this, so I put the quote there. But this is kind of the dramatic, fun way of thinking of it, right? So we've got this open space application, which is like the matrix. It's just a blank white space. And then we can insert into that anything we want. And hopefully, we're not doing weapons and training simulations, but we're going to do other things. So this is a blank application decorated with Morpheus and little architect up in the corner, which I was realizing looks a lot like so you've got the blank white canvas that is just a shell, and then the pieces, which we call agents, are inserted into that space to form the application. So I've got a demo app here. So this is our shell application, which isn't white. I just put a background on it because I want to show some visual effect that one of these things demonstrates. So inside of it, it's just a shell. We can look at the code. It's actually very simple. That's all that's here. But one of the things that's here is it's going to instantiate an ALOHA application and then begin a load of a set of VIs that is defined from some configuration file. So if I hit run, you'll see that it brings up gradually launching the various modules that are part of the program. There are a few of them here. There are additional ones that are hidden, which I'll show you in a moment. But you can see the top bar is a very typical part of an application. And this is an agent, this is an agent, and this is another SmartCom console agent. All of these are connected together with a protocol called SmartCom, which is a messaging system that just connects the agents together. And I'll go into quite a bit of depth in that because it's kind of core to how ALOHA works. But basically what you have here is these independent pieces which have controls on them and indicators. And if I flick this one, you'll see that the Boolean on the other one changes. And we also got a message down in the console here. So you can see that's actually the loop that's going across that's allowing us to communicate. And the communication is bidirectional. And there are a bunch of standard kinds of things that the agents do to communicate to each other. And then these are controls that we put on there. I just put some nice looking iPhone-like controls on here just to kind of dress it up a little bit. But you can see there is passing data from one to the other, or passing control information. You can put in a string here and I can push it from one to the other. Or I can also, if I want to, I can query it from another one. I can get access to some piece of information that it has to offer. So it's both a command broadcast kind of system as well as a request for information. And those messages, like if we look at the Boolean true message here, are messages that I can send out from anywhere. If I send that out true, typo. And then you'll see that's a lightning element. So some of the GUI elements that are done here for you, I've got some demonstration up here, and in this agent here, we can slide the agents on and off. We can swipe them.
And this is all provided by ALOHA?
Yeah, ALOHA is doing this. So and I'll show you what these pieces are, individual pieces that are small VIs that are simple producer-consumer, very small, simple packages that just about any LabVIEW programmer can like. And then what ALOHA does is kind of bring those all together in a common environment. So one of the cool things that this can do is I can pop that window out and float it around. I can hide and show it. It has some nice fading effects. And then I can click this back and I can just dock it back to where it is. So the pieces can be scattered around however you want to. There's clicking on this icon up in the corner here that brings up an object browser. This is also just another agent. You see here there on the list of all the agents, and object browser is one of the agents. So I can go to any of these. Say if I want to go to agent 2, and I can just move it around wherever I want to. So it allows me great flexibility in what the user interface looks like. And it has the ability to remember these positions, so you can customize it. The user can customize it however they want to see it. And you can do cool things like the background can be, this one actually has a blue background. I can change it to whatever I want to, but then I can also hide the background, so it actually blends in with the background image. So it provides a more unified look. Yeah.
That just updated in 2 places at once.
What did?
You hit the button and it updated on that primary screen and the secondary screen simultaneously. So how was that being implemented? Because to me, when I saw this, it seemed like you basically have to have sub-panels through there, but you can't have multiple sub-panels, multiple instances of the same sub-panel visible at the same time. So how
is that an image on the right-hand side as opposed to a sub-panel?
This here, yes, and you can kind of see the artifacting. This is a produced JPEG or PNG or whatever off of that front panel.
It just updates every 2 seconds.
Yes, yes, and that's just, so we can see that most dramatically here if I go to the object browser, because we'll see it. It's just taking a step. So and you'll see also, like here I've got a little transparent button here. I can actually cause that to happen in the console to the agent. Those aren't necessarily synchronized. I don't have it tied into that button, but I can cause it to be transparent. This, basically the idea with the object browser is it gives you a way to bring in all of these agents, because once you get a complex program, you might have many, many agents, and it can help you bring them into a single environment, move them around, get them positioned the way you want to, rather than running through a million iterations of a configuration file and starting. We can look at some of the code in a little bit. I wanted to go through a little bit more of the what is it first, so I'm going to pop back to the application. So here again we see modular applications, small pieces, conveying a bigger application. One of the nice things about that is it makes it easy for multiple developers to work on it, because I can work on one set of agents and I can have one of my other engineers work on another set of agents. We can each do it, prototype them in our own blank architect space, and then when we're ready we can bring them together and test them. Again, one of our design objectives was to really keep it simple so that we build off of really common design patterns, specifically the producer-consumer state machine type patterns. Basically, the form is a huge state machine, is what the agents generally look like inside. Although you're free to do whatever you want to inside the agents, there's just a few simple things you need to do to tie into the ALOHA part. But I've got many engineers that work for us at Seneca 5 that are competent LabVIEW programmers that are not going to be competent if I throw a really complex architecture at them. So this is something that gives them the ability to be productive on a part of the code that I can spin off to them, and no CLA is required. I mean, there are plenty of good LabVIEW programmers that I work with that are not going to be CLAs. That's just not where they're going. But we can participate with them and allow them to participate in building large, complex applications for the system. We also get code reuse out of it, because if you write an agent properly, thinking of a nice generic use case for it, you'll end up with an agent that you will use over and over again, like the control bar that I just showed you in the application that we were just using. That's one that was on this really early application that we did. That control bar has made it into just about every application we've done since, some variation of it. This button bar, very similarly. There are common elements that you'll use over and over again. And the really nice thing about the way that ALOHA does it is it's not just a piece of example code that you're grabbing from an old project and rolling into your new code. You can actually take the whole agent as is and just insert it into the application and begin interacting with it. So we get some of the advantages of object-oriented programming without the complexity on the implementer of knowing exactly what they're doing in an object-oriented sense. So we have these agents that exist that have their own state information. They've got data that they're working with, and then there are methods, which are our messages on SmartCom that we use for all the other agents to talk to them. So we create an OO-like space without actually having the users be concerned with actual code. This is just kind of restating some of the same stuff. It just helps for team development. You can, if you're working on an agent by itself and someone else is, there's no dependency in code between them. You're only connected through the messaging system. So you can independently have them open, edit them, make changes. No one's going to be out of sync or stomp on anyone else's changes when they go check it in to the revision control. And the main thing is here again, we free up the programmer to work in the problem domain. Just like test stand constrains the developer to writing a test that flows into a test step, we can create an environment that constrains the user to writing a piece of code that is a part of a program that we've defined for them. These are some various example screens. This is a system that we've used over the course of many years. So things have developed, we've gradually added features to it. So you'll see, I don't know if you recall, the one that I showed earlier was a version of this same screen, but it wasn't as nice looking. We went back and we have the transparency now and other features that really dress it up a lot. But one of our big goals was really, it's been very useful in a lot of interactive systems. There's also some versioning built in. It's when you instantiate each of the individual agents, you give it information like a name, a version number, description. That becomes very helpful when you get a program that has lots and lots of agents in it. And this dialog is just something that's available as a pop-up that just enumerates everything that's there. It becomes more complex tracking version information when you've got 20 pieces that all have their own version. And you can actually update one of those pieces without updating other pieces. There's no longer the concept of a version of an application. So it's actually an interesting problem to try to deal with. All right. Any questions just generally? Did I hammer that into the ground well enough? What we were trying to do? Yeah, you know.
The last thing you said, I just want you to say that one more time. You said, as far as updating components of an application, you're actually allowing, just say it again.
Okay. So since the application is built out of a whole bunch of pieces, it's very possible for one of those pieces to be updated. And your application doesn't necessarily have a version. It's kind of like your iPad. You can update one app and not another. You don't have something that says what version of your iPad it is.
How are those components, those are dependencies though of the application that you're updating. Are they project libraries, or how are you updating them?
Well, so in a practical sense, I would love for it to be able to work where these agents are something that we could just bring up into a running LabVIEW application. But for practical reasons with LabVIEW, that's not been something that we've been able to achieve. So what happens is, in the environment that I was showing, that's a runtime environment, and we're just kind of loosely loading whatever we want to, but they're loaded dynamically. When we go to deploy the application, they all get built into an executable. So in that sense, they literally are one distributable at that point. But honestly, I think it would be a better system if it worked, that those are modules that could be attached later on to a pre-existing LabVIEW EXE, where we could insert a module into that space.
Have you explored strategies to do that?
We have, and it actually worked. When we first wrote this, it was in LabVIEW 7.1, and it worked a lot better before the namespaces came along. So, and it's still kind of, in concept, it can work, I guess, as long as you get all of the dependencies and memory that it needs, then you're able to load the things it's dependent on. It's just,
It's tricky.
it's difficult, you know.
That's actually nothing for a sidebar. Just updating what you described online. I'm saying that would be a topic I'd love to explore more on Wednesday.
Delivering modules.
Yeah, like but being able to update or deploy systems without having to rebuild the entire system.
EXE patches?
Yeah, called patching.
Or like plugins that are attached to a precompiled program that are not part of the executable.
Right.
Yeah.
What do you typically use to test these agents by itself, and then you have an extension framework that allows you to test it in the context of the...
So it depends on the complexity of the agent, really. If you have a simple agent, it might be perfectly acceptable to just use the command console window. Just by using this window here, we're able to see everything that goes across the message bus to all of the agents, and we're able to initiate those messages as well. So you could just go through a script of what you want to test your agent for.
Is that script automated?
Sure. Yeah. We've got many agents that we've used to automate the scripting. This is just a simple text-based language, so you can record and play back scenarios to it and run through whatever scenario you want to.
I suppose I might be getting ahead to the how it works stage. If that's okay, then that's fine. My question was, can any agent send any message to any other agent, or are there limitations on who can talk to who and what they can say?
Yes, you're getting ahead. Awesome. That's the first thing we're going to dive into, actually, because the kind of the fundamental backbone of how this works is the communication between the agents. Now we've provided the space for the agents to be loaded, the very next thing we need to do is allow them to talk to each other because they are trying to be an application. They need to be connected. There are a few other features here that we can kind of look at. One of the interesting things that just kind of came up from the previous talk was handling any files. We have a way of doing that in here. Basically, any time an agent is loaded, whenever it's unloaded, it takes everything that's on its front panel and it writes that to disk. And then when it starts up again, it reads it back. So you can override that and set it to a default if you want to, but automatically all of your data is persistent. All of the data is a simple data type, as we clarified. It doesn't, you can't do it with a structure, a cluster, or something like that. It would be complex, but simple front panel controls get memorized and restored. As do the window positions and that sort of thing, which help make the GUI work together. So this is what's going on kind of inside. You've got these agents that all exist inside the space, and they're all connected to this bus called smartphone, which is a messaging system that goes between all of the agents. This is one of those things that, like I said earlier, you make one decision, and by doing that, you're specifically deciding not to do it other ways. And this is one of those things that is one of those choices we made. And it is that, first of all, the messages are strings, simple strings, not a data, a cluster or anything like that. So they do require a little bit of extra parsing, but we think there's some good advantages for that we've used. The parameters are part of the string. So we just have space delimited parameter list, and that can be as long as you want to go. And we allow a OO-like notation for targeting, which kind of answers a little bit of your question, your start scheme. You can direct a message for a particular agent by using a name, or there's an alias in the system as well. So in this case, we have an agent called PS1, parseline1, that we want to set its voltage. So we just use a PS1.voltage, kind of a standard OO-like syntax to send a message to that. Every message that is generated inside of ALOHA is broadcast to every other message. So in this case, we've got agent 2 sending out the run test 42 message, and you see it shows up at all of the other agents, just like that. Not every agent has to do anything with it. In most cases, you're going to ignore most of the messages that come across the bus, but you get the message.
Is that true even for those messages with a target?
Wow, did you write the next slide? Yes, even when they're targeted. But there's a difference. So the agent N there is saying power supply 2, set your voltage to 4.2. These are two instances of the same agent. They're both power supply agents. They're both running the same code. But one of them sees that the message was for it, and it gets a this dot. The other one just gets PS2 dot. So in your code, you implement responding to it on this. And it acts on the message to PS2 when PS2 gets it. And if we send the message out to PS1, then the other one would act. So that's something that we added again as we morphed the platform along, and we needed to have multiple instances of the same sequence. One of the nice things about having
Very
a
quick
simple,
question.
yeah.
Because I've seen this behind the scenes. So then every agent knows its name. And then when every agent, like PS2, sees a message coming to it internally, then it translates that to this. And so that's part of what someone needs to know when they're getting up to speed, correct?
Right, yeah. So any agent, and you can also know, so if someone sent a message explicitly to it, it would know its own name. But the easiest way to think of it is any agent knows itself as this, which is also just kind of the whole kind of concept of it. Yes.
Is SmartCom doing this substitution basically?
Yes. Yeah.
Okay, so the agent isn't saying that this is a message for me because it has my name in the front. SmartCom is saying,
right,
this one's a bit.
Right. It's already unpackaged for you, and it actually gets translated. So, yeah. And not just the name of the thing PS2. It can have any number of aliases. Every agent can. So we ran into some situations where we needed to do that. You could actually have multiple agents that are aliased to be the same name that can get messages as this, which was an interesting situation that we ran into, but we did need to do that at one point. Yeah.
How do you instantiate multiple copies of the same agents? Is it just
so for every agent, there are two parts to it. The part that the user writes is a simple producer-consumer, which we'll look at. But then there's also an actual OO representation of that in the background. So it actually keeps track of its own set of data and all of that internally to ALOHA. And then it just spawns an instance of another VDOC that it launches by name. So this is just an example of ways that, yeah.
Do you have any kind of type safety that you impose on the strings, or is it all just? Do you have any kind of type safety that you impose on the strings, or is it all just string manipulation?
The strings are completely free form. There's just a few simple rules about it. They're space delimited for parameters. If you want to put in a string parameter, you can put quotes around it that includes spaces, that kind of thing. But it's just, it's mostly passing. The idea was to keep it a human readable string, though it doesn't have to be. We have put compressed data in the strings as well. Pretty much everything will get through. The space is really the only delimiter. I'm trying to think if there were any other caveats to that. But pretty much any user-readable string is definitely going to work. And I think we've successfully used encrypted strings before. I don't think there's any restriction on the handling of special characters. Does that answer your question?
No, I guess I was asking more about type safety. Do you impose a type system, or do you have...
For the actual data that's going across in the parameter?
Yeah, you just sort of send out any string, and you leave yourself open to a lot of errors and typing-related errors. Not typing as in typing with keys, typing as...
Data typing.
Type space, right? Data type,
yeah. Yeah. So, no, there's not. So, the idea here is the onus is on the receiver of the message to interpret it properly. So, if someone says, I'm the interpreter of the set user message, then I know that the first parameter is a string, which is the name of the user. And the second parameter is whatever, the login privilege level or whatever. Those are just made up, so they don't make sense. But as the consumer of that message, I'm the one that has to know the type of the data that's in there and do any kind of type checking or anything that I would want to do with that. That's one of the downsides of having a free, open networking system like this. You know, the message can be malformed as badly as you want to malform it.
So, quick comment on that. This discussion comes up a lot. Type safety versus a more free-form method like this. And if you're going to have a lot of decoupling between your components, then you need to make your data in a form that LabVIEW understands. So you can create type defs or whatever you want to do for your data to get type safety, but that also leads to more coupling between your components. And in this particular system, Craig is specifically looking for a high amount of decoupling so individual developers can work on it. And I imagine at some point you have an interface defined that this is what this agent is going to receive, this is what messages it can receive, and this is the format of those messages. Right. And then the onus is on the developers to make sure that they are writing those messages correctly.
Yeah, at some level, there's a top-level developer that is controlling the whole application space and what agents are there, what messages are being sent around the bus, what ones are good messages, what ones are bad messages. There's nothing that says, you know, when I send out this set user message, there's nothing that says that there's anyone out there to receive it. Now, we can put in our own mechanism for verifying that, but that's something that we have to do in our own messaging scheme. So it's very open, as you said, very loosely coupled. And the reason for that is we want to be able to have modules that we can pick up from one application, put into a totally different application, which might be doing something completely different, but still use that same simple set of, it's basically an API, but it's exposed in a set of messages, which you need to know in order to talk to them.
I was going to make a comment about I could easily either each module convert from a string to a. You can easily switch from a string to a numerated type internally with each module if you're worried about mistyping or.
Sure. And so I'm going to go ahead and bring up some code here so we can look at what some of this really looks like. How are we doing? So this is my application, and the main application is what we run, but anytime we want to, we can go look in the agents are just a directory that live off of the main application in this case. And we can go look at what the code looks like for one of those, which unfortunately doesn't look really good on this screen. But there's an agent is quite simple by design. There's a couple of initialization things that you need to do right at the beginning. We don't even have to do this .ready in this case. It's just queuing up so that we're going to run a piece of code after it boots up. But you create this code, and then when you run it through ALOHA, ALOHA gives you a this pointer. So that's just something that's constructed for you, and that's your connection back into ALOHA. So all the OO stuff that goes on behind the scenes, and now you're just connected up to it, and you're able to use all of those functions. These are some of the functions here. There's a little all public functions. One of the things on the to-do list is to make a proper release of this where we can have nice palettes and that sort of thing. It's just hard to maintain because we keep changing the underlying system. So I just keep this here, and this is basically the API for ALOHA. We've got an app object and we've got agent objects. Each instance of an agent that you're writing has an instance of an app an agent object existing inside of ALOHA. And then these are all the things you can do with it. There's GUI functions, there's attribute getting and setting. So for the messaging system, again, we've just got kind of a cute state machine sort of model, producer, consumer, where the consumer is running off of a list of states, which are essentially the messages that are coming in. So this parser breaks the message apart. The main thing here that's coming off is the base message, and then the parameters are spread apart for you. If you want to use them, there's any of them doing it in this case, but yeah, you can see different ways that we're using them. This one just does a simple comparison to see if it's a T that it's true or not. Because you're going to get all the parameters in string form, and you need to translate them on. There is another mechanism which I was showing here by this tick. I don't know if you noticed earlier, it's flashing on and off, but it was not flooding the bus with tick, 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 because there's a lot of things that you want to do sometimes inside of an agent that you don't want to flood the bus with a bunch of information. So you can do this is a send self a message, in which case It's just like sending a message on the SmartCom bus. It's the same message, it's parsed the same way, but it only shows up on your own page. And there's just a simple flag that you can use to send it to everyone or to yourself. So the bottom loop here is the implementation of basically how you're responding to any particular message. And that's the essence of your API that you're providing with this particular agent to the rest of the system. One of the nice things about having string-based messages is we've extended that. It's pretty easy to make additional agents that, say, talk TCP/IP and bridge to another application, which also has an ALOHA framework in it, so you've got now basically two buses coupled together across two executables. The initial application that drove this was a system that I wrote that needed to have two control computers. One was in a hot room by a particle device that you couldn't be in the room, but you couldn't be in the room while it was running, but then you needed to be able to lock it out and have local control when you were making settings on the device. So you had two completely separate computers that were running virtually the same set of code and the same agents with a few differences, and one would have control over the other. So they worked really well. They were two applications actually running on two separate PCs. And then in addition to that, we had another tunnel bridging down to a compact Rio that was actually doing machine control. This is just kind of a top-level view of the agent I was just looking at. Actually, it's a different one, but very similar. You've got the producer-consumer, messages handled down at the bottom, and the queue state machine. I'm not going to go through some of this because we're kind of short on time and I want to leave some time for more questions, but just the essence that I was just kind of showing here how you kind of go about making the language for a particular agent and how it might interface to the rest of the system. This is a view of kind of what's going on behind the scenes. And people usually ask this question of how do you broadcast the messages? There's no broadcast per se in LabVIEW, but the way we do it is every agent has a queue on its incoming side. That's what's being dequeued on down at the bottom loop. This guy is dequeuing off of the queue that's specific to this agent. So every agent has its own, and we make a copy. So someone sends out a message, we make a copy to everyone's queue, and it gets to them. And it also handles, if agents are being created or destroyed dynamically, it gracefully handles that without throwing up data. Yeah.
In general, do you find that most of your agents are user interface elements or have user interface elements to them, or do you very often create agents that are purely programmatic?
We create a lot of them that are programmatic as well. In fact, show this other slide here. This is, as you're thinking about the agents and how you would do this kind of thing, reusability is very important. And actually, reusability is probably hardest to do with the ones that are GUI interfaces, because so much of that is kind of custom for the particular application. So that we'll have a lot of agents that are GUI agents that we'll make copies of and have a different version of for a different app. But the more generic ones are, think in terms of like an instrument driver. You just take the behavior of a particular instrument, you wrap it up in an agent, and now you can plug it into any system, and any ALOHA system can just talk to that device and speak out of it. Which is, it's a great model for doing a plug-in type system to talk to different kinds of instrumentation, having a hardware abstraction layer. You can simply slide in the agent that has the right implementation that talks the exact same language as the others, but it might control a totally different kind of instrument. There are also some back-end service things like the user manager, not the dialog box that comes up that lets you enter your username and password, maybe something that's custom in that application, or maybe integrated into another element like the control bar on the top. But the actual backend that checks the database and makes sure the person is authorized and all that, that's done by an agent that just sits in the background that we never even see in Parapath. It just handles operations. And then the process control would be kind of the specific logic that you would write for your program. Yeah.
So in the case where you have this back-end service where you may want to have a different UI for different types of things, are you nesting your agents, or are both of those agents essentially on the same message bus, and you somehow arrange your messages so that all of them go to the back-end component, which are then forwarded to the UI component?
Nothing's ever forwarded, because if the two agents exist in the same application space, they both get all the messages. Okay. So there would be a different set of messages that would go between the UI and the server than there would be if you were talking to the server itself.
Okay.
So yeah, there's a fair amount of programming that happens in the definition of those messages for a particular application. It's a very important part of the application, essentially the message structure itself.
Do you ever have issues when you have lots of agents figuring out where messages came from? Or is it really like a non-issue?
Issues finding out where, with a lot of agents, where do the messages come from? That is difficult to find out sometimes. I mean, obviously if you're generating those messages based on button clicks, it's easy enough to do. It's a little bit difficult sometimes. Some of the tools, like the object browser that I was showing you, you can kill an agent if you suspect that it's the one that's doing it, and then you can bring it back, in and out of the environment dynamically if you wanted to test that. But just like I was saying, the messages, the definition of the messages are very integral to the programming of the application. That sort of behavior is as well. There's always little quirks that come up when you stick two agents together that are maybe behaving in a little different way. One of the things that can happen fairly easily is you can end up with a message that generates another message that pings back and forth, and there's no mechanism to stop that. It's perfectly valid to do, but it's not desired behavior. This is just kind of just 1 second. I just wanted to put this out there because we're probably going to run out of time here. But the idea here then is we have an application is made up of these few parts. There's the ALOHA core, that's the background stuff that ALOHA brings to the table. And then you're going to have a set of reusable agents that you kind of build in a toolbox that are custom for what you do. And you'll reuse a lot of those. And then the last level is the specific ones for an application. Ideally, if you design these well, that's 80% of your program, and it's done from the start if you're writing programs that are very similar. And then you just modify the program logic and maybe add it into the controller or two for
Just want to understand your motivation behind letting everybody hear everything. So when your agents register with your smart com, they obviously pass on their queue references and stuff. So at that time, why not pass in a set of messages that the agent is interested in and only hear about those? And if not that, at least if a message is targeted, then why not just let only that agent hear about it? Okay. Because if you're unbundling that message in every agent, you're still at least looping through that once.
So most of the time you're not unbundling it in the sense of parsing it in any sense, but you get the message and you throw it away if you're not interested in it. But the real reason is the loose coupling, so that we can have runtime. At runtime we can have agents that come together and are able to interact. Good example, the user manager that I was talking about, that sits in the background and it provides a service. And I have very often a pop-up dialog that comes in and you type in who the user is and what your password is. And then you get authorized or not. And the message that comes out of the system, the slide that we just kind of skipped over, would be like if I log in as Craig and my password is 123, the message that comes back out on the bus to everyone is logged in Craig super user. So now, the reason why I want that to go to everyone is because in this case that I actually implemented, there's the control bar up at the top has a login button and it has the user. Well, now all it needs to do is look for that message and it can update the user, and it's always updated. And notice also, if we log out, the response is a log in message, which is going to go clear that.
So that makes sense for this response, but sending the login flag 1, 2, 3, 4 for the data logger would make sense because it doesn't know what to do with it.
Right. I agree, it doesn't. And actually, one of the things we always thought we were going to implement is exactly what you're suggesting, which is some sort of filtering on message, that we would have steered directed messages. But just as a practical measure, it never, I thought it was going to overload the bus, just having all of this stuff on there, because it's just a bunch of noise. But it's really nice to be able to just see, this is one set of messages, you know everyone's going to get it. And it's not dependent on whether or not they've subscribed and whether or not they've done that properly. If you go to the command window and you type in login Craig 1234, you know that everyone's going to get it. And it does help debugging.
Last question.
Yeah, do you have any mechanisms for I guess, putting a reservation on an agent? And what I mean by that is, like, for instance, if you have one agent that is a supervisor that wants to tell a loader go from point A to point B to point C, I see the potential for having another agent, come in, chime in the middle, and say go to point D. Do you have any mechanism for preventing a third party chiming in the middle of a desired sequence?
Not in the message system itself. You'd have to do that by making an agent that was like the central point for controlling the thing. You'd have to do that a different way.
Do you have more slides you can summarize?
I just wanted to point out this one. If you go to our website, there's a tab called ALOHA. You can click on it and you can download the demo that I showed here, which includes the ALOHA core that you can play around with however you want to. I did put one of those little annoying things where you have to put in use your name and an email in order to download it. That's not for any kind of spam or anything. I'm just very interested to know who is downloading this so we can start interacting.
Thank you. Good job. That's great.